In the last video, we looked at the basic principles of series and parallel circuits based on Kirchhoff's rules with the conservation of charge, the conservation of energy. And one of the things that we actually got out of it was how to find total resistance depending if things are series or parallel. We're just going to practice just finding total resistances because that's a really good place to start when you start solving circuits and that kind of stuff. Now, if you remember, we had two main rules. When resistors are in series, all we have to do is just add them up. That was pretty straightforward. And then if resistors are in parallel, then the total resistance is annoying. It's the sum of the inverses, and then you have to take the inverse of that. And we looked at the derivations of where that came from by applying the basic Kirchhoff's rules with voltage or current, and then we applied Ohm's law to them, and that's how we got the relationships. So we're just going to practice doing this nice and simple first. So for example, what if we have three resistors, and let's say this is 5 ohms, that's 8 ohms, and that's 10 ohms, and we want the total resistance altogether. Now they're just in series, so that's really simple. You got the 5 plus 8, you got 13, plus the 10, that would be 23 ohms. So that's really simple. Now if we took the exact same three resistors and put them in parallel, maybe something like this. So here's your 5, your 8, and your 10. And if we want the total resistance now, we have to do it a little bit differently. So the total resistance for this one, we have to do the 1 over 5 plus 1 over 8 plus 1 over 10. We've got to add those three fractions together. Most people just do it as decimals. Add those all up and then invert it to get the total resistance. And if we do all that, we get a total resistance of about 2.35 ohms. Now, one of the sort of the tricks of parallel circuits is when you calculate the total resistance in parallel, the total resistance will always be smaller than the smallest resistor in the circuit. Because if it was just the 5 all by itself, the total resistance would be 5. But since we also have other pathways, the total resistance, if you remember from the rules from last time in parallel circuits, if you keep adding resistances, total resistance keeps on going down. So with the 5, the 8, and the 10, I knew my total resistance had to be less than 5. If you had 10, 20, 30, the total resistance has to be less than 10. So it's always smaller than the total or the smallest resistor that there actually is. Okay, so what if we switch this up? What if we had a combination, something like this? So that's 5, that's 8, and that's 10. So a little combination setup. Well, we have to start putting resistors together in certain combinations, and redrawing is really good. So I'm not going to do it all at once. You sort of got to put things together. For example, one of the first things we can put together here are the 5 and the 8. The 5 and 8 are in series with each other. So we could actually say those two, they're like a 13. So there's no difference between that and having a circuit that looks like this and replace that 5 and the 8 with a 13. We have the same effect. Well, now I just have two resistors in parallel with each other. So I'll do the 1 over 13 plus the 1 over 10, and then invert that sum, and I'd have the total resistance for the setup. And I know that total resistance has to be less than 10. And if we actually do the calculation, we get around 5.7 ohms altogether. Okay, what if instead those three resistors looked something like this? So let's say this is the 5, there's the 10, and there's the 8. Well, in this case, I'd want to put the 5 and the 10 together first, and they're in parallel with each other. So if I do the 1 over 5 plus 1 over 10 and add that up and then take the inverse of it, I can find the equivalent resistance of just those two resistors put together. And once again, I know it's going to be less than 5 because that's the smallest resistor in parallel. And if I do the calculation, the parallel calculation, those two put together give me an equivalent resistance of 3.33 ohms. So this circuit would be the same as this one, replacing the 5 and the 10 with a 3.33 ohm resistor. Now these two are just in parallel or series with each other, so I just have to add them up, and the total resistance for the circuit would then be about 11.3 ohms altogether. Okay, so this is sort of how you put combinations of resistors together. You just find 2 or 3 that go nicely together. Often it's a good idea to redraw them, replace them with an equivalent resistor, and then just keep on going and piece them together. And often it works out pretty well. Okay, so let's try another one. Okay, so here's a combination of resistors. We got 4 different resistors here, and we're just going to find the total resistance of them all put together. Now I'm going to find a couple that I can put together nicely, and the 8 and 30 are really easy to put together. I can take these two and I could replace those guys with just a 38 ohm resistor. Okay, so now I'm going to redraw my circuit. So there's my 20 right there, that hasn't changed. And I've replaced those two on top with a 38 ohm resistor, and there's my 75 right there. Okay, so another two that can go nicely together now. Well, these two are nicely in parallel with each other, so I could switch out those guys. So I would do the 1 over 38, add that to 1 over 75, get the sum, invert it, and I can get the equivalent resistance of those two put together. And I know that the total resistance or equivalent resistance of just those two has to be less than 38. So if I do the parallel calculation, those two could be switched out with one that's around 25.2 ohms. All right, so I'm going to redraw again. So there's my 20. There's my 25.2. And they're just a series with each other, so I'll just have to add them up, which would give me about 45.2 ohms altogether, and that would be the equivalent resistance of what I started with. Okay, all right, let's try one more. Okay, so let's try this one right here and do the same type of thing. Okay, now I've got a couple of sections here I can put together, but what might throw you off is on the right-hand side of it. It looks a little fancy schmancy with that resistor being at an angle, but it really isn't. And sometimes when it looks kind of weird or strange, you just got to ask yourself, where it's connected, could I move the connection and not make a difference? But really, because really for this one right here, for this resistor going diagonally like this, there's no difference between it being connected here and it being connected here. Same thing for this could be here. So this connection would make no difference if you moved them. So it's drawn diagonally, which makes it look, tricky, but it actually isn't. You could have drawn that resistor going straight across, and it would have the exact same result. So sometimes you just got to ask yourself, if I move the connection or if it was connected here instead of there, would it make any difference? And often it doesn't and can make it look a little bit easier. Okay, well, let's start by finding some equivalent resistances here. I can put these two guys together. They're in parallel with each other. So I can do the 1 over 100 and 1 over 60 and add them up and invert it, and I can get the equivalent resistance for those guys. And that would give me an equivalent resistance. I know it has to be less than 60. Those two put together is around 37.5 ohms. Now I can do the exact same thing for these three, because these three are just in parallel with each other, so I can do the same type of calculation for those. So if I do the similar calculation, these three could be replaced or have an equivalent resistance of 23.4 ohms. All right, so if I'd redraw this, I could redraw this as two resistors, this one being 37.5, this one being 23.4, and of course they're just basically in series with each other, so I just have to add them up. So I've got the 37.5, add that to the 23.4, put the two together, and you're looking around, well, we'll just round off. These two put together to be around 61 ohms altogether. Okay, so that's just some practice using combination resistors and putting them together. It's a really common thing that you have to do with circuits, that type of stuff. And with the basic rules and stuff like that, it's not hard, and it's sort of like a puzzle. Just find a couple resistors that go really nicely together, redraw it if it helps, and then start just piecing things together.